Hello students, today we are going to learn the basic concepts of artificial neural networks. Artificial neural networks, ANNs. ANNs are much closer to biological neural networks. Our brain, that is the human brain, constitutes of nerve cells. That is thousands of nerve cells, many nerve cells. So the artificial neural network is created in a very simple fashion which is very closely related to the biological network. So in a one-line definition, an artificial neural network is an efficient computing system whose central theme is borrowed from the biological neural network. Now, ANNs are also known as parallel distributed systems or connectionist systems. So before getting into much details, that is known as receivers, it receives information from another, or you can say adjacent nerve cells. Then comes the soma or the cell body. Here it consists of a nucleus, that is the central point, and then this cell body is responsible for processing the information, and when the processing is at a certain threshold level, the information is processed, or you can say it is passed through the axon. Now here the axon acts like a cable. It passes on the data to the next neurons. So dendrites are acting as the receivers, that is the inputs. They are collecting the inputs from various other nerve cells. The cell body is processing the information via activation functions, and when that information processed achieves a particular threshold level, then it is passed on through the axon to the other nerve cells. Now you can see another terminology, that is the synapses. The synapses is a connection between the dendrites and the axon. So this is the structure of the human cell, and the artificial neural network is created upon this terminology. Now we are going to discuss as to how the biological neural network and the neural network are interrelated. So let's have a one-line definition for the various features of a biological neural network. Starting from dendrites, they are tree-like structures and are responsible for receiving information. That is, they act as receivers. They gather the inputs from various other neurons. Then you have the soma or the cell body, which is responsible for processing the information which has been received from other dendrites, and then a particular threshold is received. This is being transferred via axon, which acts like a cable to the other neuron. Coming to the last terminology, that is the synapses, it acts as a interconnection, that is a connection between the axon and the dendrite. So this was a basic understanding of a biological neural network, or you can say a simple brain, you can say the nerve cell of a brain. Come to the structure of an artificial neural network, and let us correlate a biological neural network known as BNN and an artificial neural network known as ANN. So as you can see in the diagram, there are inputs x1, x2, x3 up to xn. So these inputs are our dendrites. That is for the biological neural network, those were dendrites, and for the artificial neural network, those are inputs. Then W1, W2, W3 up to Wm, these are our weights. That is the connections between the dendrites and the axon. As you can see the next block, there is a sigma and then a function. Now this sigma and a function corresponds to your cell body. The cell body was consisting of a nucleus in its between, and it was responsible for processing your information, taking a decision. So when this summation achieves a particular threshold level, it passes on its information to the axon as it was in the case of a biological neural network. Here it is the output. So I will repeat again. Inputs are dendrites. W1, W2, W3 are the synapses. Sigma and the function F is the cell body, and the output is the axon. So this is how we can correlate a biological neural network to a artificial neural network. So this is the mathematical model of an artificial neural network. So this is the mathematical model states as the inputs x1, x2 up to xn, then the weights w1, w2, xn. Since it is a summation function, that is the activation function which we have used, so let us multiply the inputs with the weights. So there would be x1 into w1 plus x2 into w2 plus x3 into w3 plus up to xn into wn. So this is your final output. Now to the table as to how you can correlate ANN with a BNN. So in the biological neural network, the cell body corresponds to a node in an artificial neural network. The dendrites resemble inputs in an artificial neural network. The synapses for a biological neural network are the weights or interconnections in an artificial neural network. And coming to the last one, that is the axon in a biological neural network, is the final output, that is capital Y I showed you in the previous slide, in an artificial neural network. So let us have a performance analysis of the biological neural network, that is the human brain, and the artificial neural network with these parameters. So firstly coming to the first point, that is the processing. Obviously the human brain is superior than the ANN. Then the size, it is mentioned for the biological network, it's 10 raised to the power of 11 to 10 raised to the power of 15 interconnections, while for the artificial neural networks, the nodes depend between 10 raised to the power of 2 to 10 raised to the power of 4. Then coming the learning process. As we all know, the learning process is of two types, supervised and unsupervised. Supervised learning means it is being tracked, and unsupervised learning means it is not tracked. So, in a biological neural network, there is ambiguity. Yes, things may not be sure, but ANNs are precise. Then comes the fault tolerance. Now, human brain fault tolerance, it can go for partial damage. While artificial neural networks, they are robust. Their performance is robust. So coming to the storage capacity for biological neural networks, it stores information in the synapses, and the artificial neural network stores information in the memory locations. So let us see a set of applications where you can use artificial neural networks. The first one being speech recognition, character recognition, human face recognition, handwriting, signature verification. Then it can also be used for image compression, stock market, healthcare, and a lot of other miscellaneous applications. So before since we had a basic introduction to the subject. Now, what is the significance of this topic, or how you can use it to design further your projects in BTech, or how you can use it as a part of your career? So, I have listed a few advantages of neural networks, and the main point which I want to discuss is that the last point which I have highlighted also, that is AI, which is stands for artificial intelligence, then the machine learning, then the deep learning, that is via artificial neural networks. As we all know, artificial intelligence and machine learning are doing wonders, and they are having a great scope in future. So this neural networks comes under deep learning, which is a very important significance of this subject. So on the concluding remarks, I would like to highlight some very important points for artificial neural networks. The one being that they resemble the biological network, that is the human brain. Then artificial neurons and neural networks try to imitate the working mechanisms of their biological counterparts. This has already been discussed that a biological neural network, a BNN, is a correspondence to the ANN, that is a artificial neural network. Then the learning can be perceived and optimized. See, optimization means bringing the best out of a parameter. So this was all as to a basic understanding was created. And coming to the last point, the optimization is done with respect to the approximation error measure. So thank you students. So this was all in the introductory lecture on artificial neural networks.